What we're going to do is continue simplifying complex numbers. We've added, subtracted, and multiplied complex numbers. Now what we're going to do is we're going to divide complex numbers. The problem with division is that you need the denominator not to be an imaginary number. So we're going to be eliminating the imaginary number in the denominator. First, we're going to look at monomials, and that means one term, and then we're going to look at binomials. So for our first three examples, what we have are monomials, and that's when we have one term in the denominator. How we're going to get rid of it is we're going to multiply the top and the bottom by I. When we do that, 1 times I is 1I. 5I times I is 5I squared. I times I is I squared. I squared we know is -1, so this is -5. This is -1. So that 1I divided by -1 is -1I, and -5 divided by -1 is a +5. I'm going to write it in A plus BI form, which is the standard form. We put our real number first, our imaginary number second. So our answer is going to be 5 minus I. Our second one, we do the same thing. What we're going to do is we're going to multiply it by I. So we multiply the top and the bottom by I. So 3 times I is 3I. -4I times I is -4I squared. 2I times I is 2I squared. Now, I squared is -1, so that would become +4. I squared is -1, so that would be a -2. So when we divide it, we have 3 over -2I. And then we have 4 divided by 2, which is -2. Once again, we're going to write it as the real number first and then our imaginary number second. For our third example, once again, what we do is we multiply it by an I on the top and an I on the bottom. We distribute the I to each of the terms, and that gives us 8I plus 10I squared divided by 3I squared. We know that I squared is -1, and then I squared is -1. So that gives us negative 8I divided by -3 is -8 over 3I. A negative is a positive, so that would be a positive 10 over 3. Once again, we're going to put the real number first, 10 over 3 minus 8 over 3I. And so that's dividing by a monomial. Now what we're going to do is we're going to look at dividing by a binomial. So we're going to multiply the top and the bottom by the conjugate. Conjugate is just a fancy way of saying same terms, except you change the sign in the middle. It's always going to be the conjugate of our denominator, because our goal is to get rid of the i's in the denominator, and that's how we do that. So we multiply the top and the bottom by 5i. So 2 times 5 is 10. 2 times I is 2i. -I times 5 is -5i. And -I times I is -I squared. In the denominator, 5 times 5 is 25. 5 times I is 5i. Then we have -5i. And then I times I is -I squared. Now, when we're looking at this, the denominator should always cancel the i's. I squared we know is -1, so that becomes a +1. So 26 is our denominator. I squared is -1, so that becomes a +1. So that would be 11 minus 3i. And when we write it in standard form, that would be 11 over 26 minus 3 over 26i. Letter E, we're going to do the same thing. We're going to multiply it by its conjugate, 2 minus I, and then what we have is 2 minus I. We're going to FOIL it. 5 times 2 is 10. 5 times I is -5i. Then we have plus 18i. minus 9i squared. Our denominator, 2 times 2 is 4. Then what we have is minus 2i plus 2i and minus I squared. Now looking at this, we know that I squared is negative 1, so that becomes a positive 9. I squared is negative 1, so that becomes a positive 1. So the middle terms cancel in the denominator. They should always do it if you're doing it correctly. So our denominator is 5. Our numerator, 10 plus 9 is 19. Negative 5 plus 18 is 13i. When I write it in standard form, that would be 19 over 5 plus 13 over 5i. For letter F, once again, our goal is to get rid of the i's in the denominator. So what we do is we multiply it by the conjugate, 4 plus 3i, and then we have 4 plus 3i. When we FOIL it, 1 times 4 is 4, 1 times 3i is 3i, 11i times 4 is 44i, and 11i times 3i is 33i squared. We multiply the denominator. 4 times 4 is 16. 4 times 3 is 12i, negative 12i, and negative 9i squared. When we're looking at this, we know that I squared is negative 1, so negative 33. I squared is negative 1, so that becomes a positive 9. The i's in the denominator cancel. 16 plus 9 is 25. 4 minus 33 gives us negative 29, and then plus 47i. And that, of course, in a plus bi form is negative 29 over 25 plus 47 over 25i. Okay, try these next three on your own and see how you do. So for the first one, we're multiplying it by I because we're dividing it by a monomial. So it would be 1i minus 2i squared over 4i squared. I squared, remember, is negative 1, so negative 4, and that would be a positive 2. And so what we have is negative 1/4 I minus, minus 2 over 4, which of course reduces to negative 1/2 minus 1/4 I. For letter H, what we're going to do is we're going to multiply it by the conjugate, 4 plus 5i, and then 4 plus 5i. Once again, it's the conjugate of the denominator. So 6 times 4 is 24. 6 times 5i is 30i. Then we have plus 4i and plus 5i squared. 4 times 4 is 16. That gives us plus 20i minus 20i minus 25i squared. I squared we know is negative 1, so negative 5, positive 25. Our denominators, if we're doing it correctly, always the i's cancel. 16 plus 25 gives us 41. 24 minus 5 is 19. And then 30i plus 4i is 34i. So once again, when we put it in a plus bi form, 19 over 41 plus 34i over 41. And that right there is our answer. And for our last one, we're going to multiply by the conjugate, 9 minus 4i on both the top and the bottom. And when we FOIL it, 2 times 9 is 18. 2 times 4i is minus 8i, and then minus 27i, and then plus 12i squared. 9 times 9 is 81. 9 times 4 is negative 34, 36. I, positive 36i, and negative 16i squared. We know that I squared is -1, so -12 and 16. 18 minus 12 is 6 minus 35i. The i's cancel in the denominator. 81 plus 16 gives us 97. And so a plus bi form would be 6 over 97 minus 35 over 97.